In the early 1900s, Louis Camille Maillard discovered what came to be known as the Maillard reaction when he was trying to figure out how amino acids linked up to form proteins. He discovered that when he heated sugars and amino acids together, the mixture slowly turned brown and formed a charred taste.
The Maillard reaction is one of the 5 main types of reactions.
The Maillard reaction occurs when the denatured proteins on the surface of the toast recombine with the sugars present. There are 3 main stages in the Maillard reaction. The first is a reaction between sugar and amino acids.
This stage begins slowly at around 285 degrees Fahrenheit. Amino acids and certain polysaccharides are rearranged.
By the end of stage 1, the carbonyl group on a sugar reacts with a protein or amino acid's amino group, which produces an N-substituted glycosylamine.
In the second stage of the Maillard reaction, glycosylamine isomerizes.
The glycosylamine compound generated in the first step isomerizes by undergoing Amador rearrangement to give a ketosamine.
In the third stage of the Maillard reaction, ketosamine, a type of sugar molecule, can react in a number of ways to produce the melanoidins, which give the toast its flavor and aroma.
With toast, melanoidins are produced from the reaction, which are brown polymeric substances that give the toast its flavor and browning. It also allows for a charred taste. In order for the Maillard reaction to occur, it needs heat and proteins, preferably above the temperature of 225 degrees Fahrenheit. The Maillard reaction occurs in cooking almost all kinds of food, although the simple sugars and amino acids present produce very different aromas and tastes. That's why baking bread doesn't smell or taste like roasting meat or frying fish, even though all of these foods depend on the Maillard reactions for flavor.
High temperature cooking speeds up the Maillard reaction because both heat increases the rate of the chemical reactions and accelerates the evaporation of water. As the food dries, the concentration of reactant compounds increases and the temperature climbs more rapidly.
The Maillard reaction comes to a halt around 355 degrees Fahrenheit when a different set of reactions start to occur. Pyrolysis, also known as burning. The difference between pyrolysis and the Maillard reaction is that during pyrolysis, bitterness is formed, while in the Maillard reaction, it's more sweetness.
The Maillard reaction has had an effect on history not just in one era, but all of them, even before it was discovered in the early 19th century. People were using the Maillard reaction in cooking foods before they even knew about it. However, one specific example of how this reaction has had an effect on history is during World War II, soldiers complained about their eggs turning brown and developing unappealing flavors. Then, after many studies done in laboratories, scientists figured out that the unappetizing tastes were coming from the Maillard reaction. We expect the toast to become darker and crispy.
Return to the Mac. Get up what it is, what it does, what it is, what it isn't. Looking for a better way to get up out of bed instead of getting on the internet and checking a new hit. Me get up. First shot, two strut walking. A little bit of humble, a little bit of cautious. Somewhere between like Rocky and Cosby. Swear to game, no, y'all can't cut me.
Angles. Now you move around the toast.
It's a party.
This is weird, Connor.
I shake my skin and put my bones into everything I record to it. And yeah, I'm on. Let that stage light go and shine on down. Got that Bob Barker suit game and Plinko in my style. Money, stay on my craft and stick around for those pounds. But I do that to pass the torch and put on for my town. Trust me, on my IND.
Damn it, stop moving the toes. Oh, look at it in the light. Oh, I walk around. Oh, it's like God. Nice one.